Hi, today we are walking through the topic 7 remediation, which is all about polynomial operations. So if we start off with our first two questions, we want to simplify and name the polynomial, and they're letting us know that our answer must be in standard form. So if we take a look at our two problems, the first one, we have a polynomial over here, and we're adding it to a second polynomial. And then in the second problem, we have a polynomial here, and we're subtracting it. So the thing that we need to remember when we're adding and subtracting polynomials is that you can only combine like terms. Like terms are going to be something that have the same variable. So if I highlight this 8x to the fifth power, it has to have the same variable, and it has to have the same exponent. So if I scan in my second polynomial, I see some that have the same variable x, and this one right here, negative x to the 8x to the fifth power, has the same variable and exponent combination. So I'm going to color code them, and I'm going to add them together. So 8 plus negative 8, and when we think about that, when we add a negative number, we're really subtracting. 8 minus 8 is 0. So this one's a little bit weird, but these two guys are going to cancel each other out. So now I'm going to move down the list, and I'm going to go on to my next term. I have negative 3x to the third power. So I'm scanning in my second polynomial to see if I see anything else that has x to the third. Well, I see here I have 6x to the third power. So I'm going to go ahead and add them together. When I add them together, I'm adding their coefficients. What is negative 3 plus 6? Well, this time it's not 0. Negative 3 plus 6 is positive 3. So I'm going to put 3x cubed down, and I'm going to cross them off because I've already used them so I don't get confused. I can keep my work neat. And then I move on to my next polynomial. I have 4x. I'm looking for anything that just has a plain old x in my second polynomial. I have negative 2x. I add their coefficients. 4 plus negative 2 is the same thing as 4 minus 2. And 4 minus 2 is a positive 2, and the x just comes down. Nothing changes about the x. And moving on to our next one, I have a plus 5. I'm looking for anything in my second polynomial that has just a plain old number. I have a plus 1, and I want to add them together. 5 plus 1 is 6. I'm going to cross them off because I've used them. And last but not least, I have an x, or a negative x squared plus 3x squared. So I'm going to add their coefficients. Remember, this guy has a little invisible 1 out in front of it. Negative 1 plus 3 is positive 2x squared. I'm going to cross them off because I've used them. This is going to be our final answer, but it is not in standard form. When we're writing something in standard form, the highest exponent has to go first, and then you just go down the list from there. So the highest exponent that I see is 3. So that whole term, 3x cubed, is going to go first. But then my next highest exponent is this 2x squared. So that's going to go next. And then my next term would be my plus 2x. Remember that this has a little invisible exponent of 1. And then last but not least, all of the constants go at the end. When we want to find the degree of a polynomial, that is the highest exponent. So the degree of my polynomial is 3. The number of terms, I always count them between the like plus or minus signs. So this is a term, this is a term, this is a term, and this is a term. So there's 1, 2, 3, 4. And to name our polynomial, anything that has a degree 3 is called a cubic. And 4 terms we're just going to classify as a polynomial. Anything greater than 3 we'll just call a polynomial. It's a cubic polynomial. Now, the second question here is very similar to the last one, except for we're subtracting. So there's one little thing that I like to do first before I match up my like terms. I like to turn my subtraction into an addition problem. And I'm going to do that by distributing that negative sign. My first set of parentheses is going to stay the same. So nothing's going to change there, but I'm going to turn it into an addition problem by distributing that negative. So this polynomial right here is going to turn into negative 2x cubed, and the negative times the negative is going to turn this into a positive x. And now we can do just like we did in our last problem. I'm going to match up my like terms. So I have a 4x is first, so I'm looking for just a plain old x in my second polynomial. Remember that this x has an invisible 1 out in front of it, so if I take 4 plus 1, I get 5x. I'm going to cross them off because I've used them. And then my second term, my 3x cubed, matches up with this negative 2x cubed, and I'm adding them together. 3 plus negative 2 is the same thing as 3 minus 2, which is 1. So plus 1x cubed. Remember to write our answer in standard form. The highest exponent has to go first. So I'm going to do x cubed plus 5x because this was a positive, so it's a plus 5. My degree is the highest exponent that we have. The highest exponent here is 3. The number of terms, I have 1 over here, 2 over here. So there's 2 terms. So the way we're going to classify this, again, first the degree is 3, so we call that a cubic. And when we have 2 terms, we call it a binomial. I think of like a bicycle meaning 2, a binomial. So section 1.1 was about adding and subtracting polynomials. Now we're going to jump down to section 7.2 and 7.3, which is multiplying their polynomials. So we've got these handy dandy little boxes here to help us out with our problem. And they're just ways that we can keep our work organized. So I am going to take my polynomial, or like my problem here, and I'm going to write them across the top and the side of my box. So 2x plus 1, I'm just going to write at the top. So they kind of each get their own column here. And then I'm going to take my 3x plus 5, and I'm going to write it down the side. So what we're going to do here to multiply is we're going to look at this box right here, and we're going to take the term above it and multiply it to the term at the left. So we have to remember what it means when we're multiplying 2 terms together. We take their coefficients and we multiply them. 3 times 2 is 6. And this is the tricky part to remember. X times x is x squared. So remember, we add their exponents together. So that's going to be my first box. So I'm going to drop down to my second box. I'm multiplying here 2x times 5. So the 2 times 5 is going to result in a 10. And then this x doesn't have anything to multiply by, so it just gets to come down and join the 10. It becomes 10x. And then we do the same thing for our last 2 boxes. In this box right here, we're multiplying 1 times 3x. 1 times 3 is 3. And then x times nothing is just x. And then last but not least, we have 5 times 1 to fill in this box here. 5 times 1 is 5. Now, just like we did in our last problem, we need to find any like terms that we're allowed to add or subtract together. And a lot of times they show up on these diagonals. And I like these box problems because they tell me what to do in the middle of the box. To kind of look at that plus sign there. So I need to add those 2 terms together. 10x plus 3x is going to result in a 13x in my final answer. We need to write it in standard form. So my highest exponent goes first, 6x squared. And then I have my 13x because I added those 2 guys together. And then my plus 5 gets to go at the end. Now, our second problem over here is very similar, except for now our box is a little bit bigger, and that's because we have 3 terms in one of the polynomials. So I'm going to take this 3x minus 1, and I'm going to put it down the side, and I'm bringing the negative signs with it. We didn't have any negative signs in our last problem, but I had to bring the negative sign with this one. And then I'm going to take the polynomial that has 3 terms, and I'm going to write it across the top. X squared plus 2x minus 4. And then I'm going to fill in my boxes just like we did before. We just have a couple more boxes this time. So in my first box, x squared times 3x. Well, remember this has an invisible 1 out in front of it. 3 times 1 is 3. X times x squared is x cubed. So we add their exponents. 1 plus 2 would give us 3. This has a little exponent in here of 1 as well. So let's remember that. 3 times 2 is going to give me a 6. X times x is x squared. And then lastly, 3 times negative 4 is negative 12. X doesn't have anything to multiply with, so it just comes down and becomes x. Our next row that we can do, 1 times negative 1 is negative 1, and the x squared doesn't have anything to multiply by, so it just comes down and joins the negative 1. 2 times negative 1 is negative 2. The x doesn't have anything to multiply by, so it just comes down and joins the negative 2. And then last but not least, negative 1 times negative 4. Remember, a negative times a negative is going to result in a positive 4. And then just like our last problem, whenever we have our entire box filled in, now we're looking for like terms to combine. So I don't see anything with a 3x cubed, or I don't see anything else that has an x cubed. So I'm just going to bring it down. I know it's going to go first because it has the highest exponent. But when I look at my next box, I have a 6x squared. And there is another term that has an x squared next to it. So we need to, like we did in the last problem, add these two together. What is negative 1 plus 6? Well, that would be a positive 5x squared. And now we're moving on to our next one. I have a negative 12x, but I do see this negative 2x also. So we have another set of like terms. Remember, we're looking for them along these diagonals. And our box tells us that we need to add them together. Negative 2 plus negative 12 is negative 14x. And then last but not least, this plus 4 at the end doesn't have anything to combine with, so it just comes down, and that is my answer in standard form. So we've added and we've subtracted, we've multiplied, and now we are going to divide. And this is kind of leading us into our greatest common factor. When we have a fraction, when we have a polynomial on the top and we're dividing, we can break this problem up into 3 separate fractions. Each of my terms up here on the top is getting divided by this 8x. So the first one that I have is 32x to the third power. I'm just going to write this down over here. 32x to the third power, that is getting divided by 8x. So let's go ahead and do that problem. 32 divided by 8, or this fraction right here, is something that you can type into a calculator to simplify. 32 divided by 8 is 4. And then x cubed divided by x. We have to remember our properties of exponents. What happens to my exponents when I'm dividing two terms? Well, I have to subtract them. 3 minus 1 is 2. So I'm left with 4x squared. That's going to be my first term. But I have to do the same thing with now my middle term, or my second term in that polynomial. I have a negative 8x squared. So let's do another fraction here that we need to simplify. Negative 8x squared. This time is being divided by 8x again. Negative 8 divided by 8 is negative 1. And then x squared divided by x, 2 minus 1, is just 1. So my next term in my answer, or my quotient, when we divide, our answer is called a quotient, is just going to be negative x. And I dropped my invisible 1 because I didn't necessarily need it. And last but not least, our final term that we need to divide is that 16x. So I'm going to have 16x on the top. 16x, and I'm dividing that by 8x. When I do 16 divided by 8, I get 2. And then this one's a little bit tricky. Remember, we subtract their exponents. 1 minus 1 is 0. So there are no x's or 0 x's left in our problem. So the 2 is the final result here. Sometimes you might see your teachers cross these x's off. They cancel each other out. So I'm just going to have a positive 2 at the end. So it's going to be a plus 2. Now, what we did was we divided by the greatest common factor between my three terms, the 8x. We have to do the same thing in this problem right here, but we're not given the greatest common factor. So we need to find what all of my three terms have in common. So the first thing we want to do is think about our three numbers, 25, 50, and 5. And we can write a list of their factors. 5 is easy because the only factors of 5 are 1 and 5. Now, 25 and 50 have a little bit longer lists. Well, I guess 25 is 1 times 25, but also 5 times 5 is 25. And 50, you could have 1 times 50. You could have 2 times 25, or you can have 5 times 10. So I just wrote a list of my factors, and the greatest common factor is the largest number that they all have in common. So what's the biggest number that each of these three numbers share on the list? Well, it's 5. And my little trick for you is always check to see if the smallest number in your problem is the greatest common factor. That's always a good one to use. And then the other thing we need to check is to see if they have a variable in common. So this one has an x to the third power. This one has x squared, but this 5 doesn't have an x. So it does not have, our GCF is not going to have an x in the problem. Whereas in this one, if we look at our numerator here, x cubed, x squared, and x, each of our three terms had an x, which is why there wasn't this x in our GCF. So if we want to write our GCF, we're going to just say that it is 5. And when we write the factored form, or when you're asked to factor out the GCF, that means that we're going to have a 5 on the outside of a set of parentheses, and we got to figure out what those leftovers are, the remainder of this problem right in here. And that's where the quotient goes, what we just found in our last problem. So we're going to take this polynomial here, and we're going to divide every term we see by our GCF. So I do the fraction 25 divided by 5, which would result in 5. There's no x on the bottom, so that x cubed isn't going to change. And we just have to do that with each of our three terms. Negative 50 divided by 5 is negative 10. X squared isn't going to change, so I'm just going to bring it down, negative 10, x squared, and then last but not least, negative 5 divided by 5 is just going to give us negative 1. So what we just did when you're factoring out the GCF of a polynomial is we kind of undid the distributive process. We found what each of these three terms had in common. We put it on the outside, and we got some leftovers remaining in a set of parentheses. So on the front side of our paper, we added, subtracted, multiplied, and divided. And we're going to flip over. And now we're going to be talking about factoring. And factoring shows up when we have a problem like this polynomial right here, and it doesn't have a GCF. So we need to come up with a different strategy that we can use, or a couple of different strategies that we can use to factor something that looks like this that doesn't have a GCF. So one thing that we can do is we can factor by grouping. And this works well when we have 4 terms in our polynomial. And we have a box here. Remember how we were multiplying and we used this box to multiply two things together? We're going to use that box, but we're going to do it backwards. We're going to pretend like this is our answer, and we want to figure out what the two terms were that we multiplied together. So what I'm going to do is I'm going to take my 8x to the third power, and I'm going to put it in my first box. And then I'm going to put the negative 64x squared in the second box. I'm going to put the positive x in the third box. and then negative 8 in the last box. And when we are factoring using the box, what we were trying to find is the greatest common factor of the rows, wait, those are columns, and the rows. So I like to just cover them up. And the question I'm asking myself is, what do 8x cubed and x have in common? Well, it might be helpful to write a 1 out in front of this x. 8 and 1, do they have any common factors that divide both 8 and the number 1? The only number out there is 1. And then we are thinking, what do x cubed and x have in common? How many x's do they share? They just share 1x. And we're going to do the same thing for the second column. What do negative 64 and negative 8 have in common? Do they have any common factors? Well, they share an 8. And then this term up here has an x squared, but this term doesn't have an x. So this 8 is the only thing that these two terms have in common. Now, because this box right here, the box closest to my number 8 is negative, this 8 is going to have to become negative as well. This box closest to this 1x was positive, so this is a positive 1x. Then we do the same thing with our rows. What do 8x cubed and negative 64x squared have in common? Well, they both share an 8. This 8 is positive, so this 8 is going to stay positive. And what do x cubed and x squared have in common? Well, this is an exponent of 3. This one's an exponent of 2. So the largest number that they both have in common is the smaller of the two. They have an 8x squared in common. And last but not least, I have 1x and a negative 8. They both don't have the same variable, so we don't have any x's. And what do 1 and negative 8 have in common? Well, they just share a 1, and it's a positive 1. So I'm going to put a plus sign there. And what we do is we take our GCFs that we just found, and we write them as our two factors. So I'm going to say this is the result of taking 8x squared plus 1 and multiplying it by x minus 8. So I just factored my grouping. And we can do the same thing for our second problem over here. Just requires us to fill in our box. We have 12x cubed plus 2x squared minus 30x minus 5. This time we have some smaller numbers in here, so hopefully it goes well. We're trying to find the GCF of my first column. So I'm asking myself, what do 12 and negative 30 have in common? Well, my factors of 12, if I need to make a list, are 1 times 12 and 3, 2 times 6 and 3 and 4. And my factors of 30 are 1 and 30, 2 and 15, 3 and 10, I ran out of space here, 6 and 5. So I'm trying to find the largest number that they both have in common, and that would be a 6. So if you ever need to make a list of your factors, you can. What do x cubed and x have in common? Well, they share an x. Do 2 and negative 5 have any common factors? They do not, so it just turns into a 1. X squared, and there's not an x here, so it's just going to be an x. And we'll do the same thing with our rows. 12x cubed and 2x squared. Well, 12 and 2 share a 2. X cubed and x squared share an x, and we take the smaller of the two exponents. They share 2x squared. And then negative 30 and negative 5 share a 5, and because the box closest to it is negative, that 5 is going to become a negative 5. So we can write our answer as 2x squared minus 5 times 6x plus 1. This works well using our box backwards when we have 4 terms. But if we take a look at our next two problems, these polynomials that we're trying to factor do not have 4 terms. They only have 3 terms. So what we get to do is I'm going to use the X method and then the X box method. Sometimes we got to use the box there as well. The first thing that we want to do when we see a polynomial that has 3 terms is identify their A, B, and C term. So A is the first number that we see, the coefficient of our first term, and this was just an x squared. So we've got to remember that there's an invisible 1 out in front of it. My B term is that middle term, which was 5, and my C term is the last one, which is negative 24. Remember that we bring the negative sign with it, and notice that I don't have any x's over here. These A, B, and C are just the coefficients. And the X box method that we can use here requires us to do a little bit of like a number puzzle, I call them, where on the top we take A times C, and at the bottom we put our number B. So A times C means I'm taking 1 times negative 24. That's negative 24. And then my B term is 5. And what I'm trying to solve for here is 2 numbers that when I multiply them together, it gives me negative 24. And when I add them together, it gives me 5. So I'm going to make a list of my factors of 24. I know that I could be 1 and 24, but when I add them together, it doesn't give me 5. So I could also check 2 and 12, but when I add them together, it doesn't give me 5. I can check 3 and 8. But here's the thing. When I add 3 and 8 together, it gives me 11, which doesn't match up with my 5. But I need my factors to result in a negative 24. So what I need to do is either make the 3 negative, or I can make the 8 negative. And they're both going to result in a similar answer when I add them together, but only one of them satisfies my puzzle over here. So if I took negative 3 plus 8, that gives me a positive 5. And if I did positive 3 minus 8, that gives me a negative 5. So we want the one that matches up with our B term, which would be this set of numbers right here, the positive 5. So my number puzzle answer solution is negative 3 and positive 8. And what this factors as, the factors are things that look like this, where you have 2 sets of parentheses grouped together. So I'm going to write my parentheses out. We take our variable and we write it first. So I have x and an x. And then my number puzzles my answers to my number puzzle get to come and be in my parentheses. So I'm going to take the negative 3, negative and all. And then the positive 8, we can put a plus sign there. It's going to result in a positive 8x. So we've got x minus 3 times x plus 8. This, we can go from our number puzzle to our factored form right away, only when a is negative 1. But if we look at our second problem over here, my a term is not 1. It is 6. My b is 13, and my c is negative 5. So this case is where we have to use the x and the box method, the x box method, our favorite way. Remember, at the top of our number puzzle, we have to take a times c. I have to take 6 times negative 5, which is negative 30, and b goes down there at the bottom, which is negative 13. I'm looking for 2 numbers that when I multiply them together, it gives me negative 30, and when I add them together, it gives me negative 13. So when I think about 30, I'm thinking about 3 and 10, but 3 times 10 is positive 30, and I want it to be a negative 30. So negative 10 plus 3 is negative 7. That one doesn't work. And then 10 times negative 3, when I add those guys together, it doesn't work either. So now I got to check a different set of factors. So another set of factors I know about 30 are 15 and 2. So if I make one of these negative, negative 15 plus 2 equals negative 13, which is exactly what I wanted. So my two factors that satisfy my number puzzle are negative 15 and 2. And the reason why we can't go straight from our number puzzle to our answers because of that 6 right there. That 6 is my leading coefficient. So I need to take this and I'm going to put them in my box, and then we're going to do our method that we did up here. So this has a little bit more steps than our last one. Our first one goes in our first box. Our last number goes in our last box. And then in my two empty boxes, instead of filling it in with the 13x, I'm going to turn it into a negative 15x and then a positive 2x. So my answers from my number puzzle get to go in my box. Now I'm going to factor out their GCF. What do 6 and 2 have in common? Well, they share a 2. X squared and x share an x. Negative 15x and negative 5 share a negative 5. 6x squared and 15x, they have a 3x in common. I wrote a little bit too close to this box. And then 2x and negative 5 don't have anything in common, so we write a 1, and it's positive. That's a little hard to see. So we have our two polynomials that we got from our box method, and then we write them as our factored answer. 2x minus 5 times 3x plus 1. And last but not least, in topic 7.6, we also talk about special cases. So if we think about what we've just done, we did problems where we had 4 terms. We did problems where we had 3 terms. And now there's a special case that we can factor when we have 2 terms in our polynomial. And this is called a difference of squares. And both of these are differences of squares. And they have a pattern that they follow. So if we had something that was like a squared minus b squared, so if we had 2 square numbers, it factors as a plus b times a minus b. That's just our special pattern. So let's think about if this x squared is a squared, it's going to factor as an a, just a plain old a. So how do I get rid of the squared? I take the square root of it. This is going to factor as x. So in my factored form, I'm going to have an x in both of my parentheses. And if this b squared was 100, what's the square root of 100? Well, it's 10. And that's something you can put in a calculator if you need. So one of them is going to be a positive 10, and the other one is going to be a negative 10. So it just follows a special pattern here. And we can do the same thing with our second problem over here. When we see 2 terms and we're factoring our problem, the numbers 25 and 36 stand out to me because they are perfect squares. So I'm going to take the square root of them. The square root of 25 is 5, and the square root of 36 is 6. But this one's a little bit special because it has the x squared out in front of it. So remember what we did in our last problem? What's the square root of x squared? Well, it's just x. So now we've got our 2 terms, and all we have to do is assemble our parentheses. So we know both of our parentheses are going to start with a 5x. And then in the end, the 6 is positive, so I'm going to have 1 positive 6 and then 1 negative 6. So we're following that pattern. So the first 2 A's are going to be the same, but B terms, one of them is positive and one of them is negative. We've got some factoring tips down here at the bottom if you want to read through those, but that's going to be the end of this video.